An eclipse is when one astronomical body blocks another. In the solar system, all eclipses have to do with the sun. The sun shines light on everything in the solar system. That means that everything in the solar system casts a shadow. These shadows have an umbra and a penumbra. The penumbra is a zone where the sun is partially blocked by the object. The other side of the sun isn't, so it can shine light into the shadow, making it not quite black, but a gray. The umbra is the zone where the sun is fully blocked by the object. The farther you get from an object, the brighter the penumbra gets and the smaller the umbra gets. Eventually, the penumbra is completely gone because the object looks smaller than the sun. The first type of eclipse is a solar eclipse. This eclipse occurs when the moon orbits directly in front of the sun so that parts of the earth fall under the moon's shadow. This kind of eclipse relies highly on perspective. You need to be in the right place on Earth to actually see it. The first subtype is a partial solar eclipse. This subtype happens when the moon doesn't line up perfectly with the sun. The moon's orbit may take it a little bit above or below where the sun is. This makes the sun look like a crescent for a short period of time. The second subtype is a total solar eclipse. This occurs when everything is just right and the moon passes directly in front of the sun. This allows the sun's upper atmosphere or corona to be visible. This eclipse makes it dark in the middle of the day and a ring of light where the sun should be. If the moon had an atmosphere similar to Earth's, the sunlight ring would look red, casting a dim red glow over the world. Finally is the annular solar eclipse. This subtype occurs when the moon happens to eclipse the sun when it is farther from the Earth in its orbit. The moon's orbit is close to a circle, but not quite. This allows for distant moon eclipses where the moon is far away enough so it looks too small to fully block out the sun. This eclipse also looks like a ring of light, but it is thicker. These subtypes of eclipses would look like this from the moon, either a black spot traveling across the Earth or a large gray circle traveling across the Earth. The second type of eclipse is a lunar eclipse. This occurs when the moon orbits directly behind the Earth and ends up in the Earth's shadow. You can view this kind of eclipse from anywhere on Earth that it is nighttime. The first subtype is a penumbral lunar eclipse. This occurs when the moon isn't lined up quite perfectly to go through the Earth's umbra, so it goes through the penumbra. This turns the moon gray, not black, because only some sunlight is blocked. This eclipse can turn the moon fully gray or partially gray, depending on how off the moon is from the center of the Earth's shadow. The second type is a partial umbral lunar eclipse. This subtype happens when the moon only goes partly through the umbra. This eclipse causes a black shadow to sweep across part of the moon then recede. The full moon turns into a thick crescent for a period of time. Finally, a total umbral eclipse occurs when the moon goes straight through the Earth's umbra. Once the moon goes black, it then turns red because it falls into a zone where sunlight that is turned red by the atmosphere is reflected back at us. This eclipse, viewed from the moon, would look like this. The Earth blocks the sun and a ring of red forms around the Earth. The third event I will talk about is not really considered an eclipse. It is called a transit. This occurs when either Mercury or Venus are lined up in a way that blocks part of the sun. This isn't considered an eclipse because although we fall in the penumbra of the planet, it is so far away that a telescope is necessary to see the planet against the sun. Mercury transits over the sun about 13 times every century. Telescopes are necessary to see this event. Scientists can use the way that the light interacts with the planet to study it. Venus transits twice every century. These transits come in pairs. 2 transits 8 years apart, then none for 100 years. Telescopes are necessary to see this event as well. Scientists can use the way that the light interacts with the planet to study it, like Mercury. No other planets transit the sun because they are never closer to the sun than us. If we lived on a planet like Saturn, then we could see transits of all the other planets that were closer to us. You may think that eclipses should happen every 2 weeks when the moon is behind or in front of the sun, and transits every year or so when the orbits of 2 planets coincide. This is not the case. The solar system is 3-dimensional. Although it may look flat in many depictions, there is a little bit of orbital inclination. Orbital inclination is the tilt of the orbit relative to Earth. Orbital inclination is low for large objects in our solar system, in the single digits of degrees, but since these objects are small in the sky, they must be in the perfect place at the perfect time to block the sun. I was going to tell you when the next eclipses are, but there are a lot of them, no less than 4 per year. In the description, I have linked this website called Time and Date. You can filter region, time frame, and type of eclipse to find the perfect eclipse for you. I would suggest that you try to see some. They are amazing.